Welcome to GC Connect. Maybe uh, yesterday we were discussing about the different important properties of the aggregate. Of course, today we will start with the different tests which are very important as the property of aggregate is considered. So, with that property, um, the first one is first test. Normally we are going to conduct on the aggregate is the first one is particle size, second one is flakiness and elongation index, the third one is moisture content, fourth one is specific gravity and water absorption ratio, or it is only water absorption. See, normally the moisture content and the water absorption, they're interlinked, that we'll discuss later. Then uh, finest test, or we can call it as a 10% fine value, or we can call it as a fineness test. Normally this fineness test is similar to the cement test, that is a cement fineness. It is similar kind of test we are going to conduct it, but slightly variation is there, but the concept of conducting the test is same. Then aggregate crushing value, then aggregate impact value, then aggregate abrasion value. So of course in this all the impact test is very important rather than crushing and abrasion. First one is impact, then the second priority is abrasion, then the third priority should be given to the crushing values. So we'll go one by one. So the particle size, of course we already calculated, we already did how to conduct the particle size determination for your cement, um, as well as for the some of the sand also and some of the soil also. Similar kind of techniques we will use it, but determination of particle size of the cement, we require high specialized equipment, because of course it depends on the fineness index of the um, the cement. Normally when you are calculating the particle size of the cement, we will use um, instrument. Of course um, that instrument is very costly. um, of course it does not require more than 1 gram. Even if you give 1 gram of sample cement to that instrument, you can calculate its particle size. Normally for the cement, we will calculate the surface area using this particle size. um, what will happen is that even if you give 1 gram of cement, it will give the surface area. Based on that we are going to calculate the particle size. Of course the particle size of cement as well as the surface area of the part, they are interlinked, and they are uh, inversely proportional. If the particle size is go on increasing, normally the surface area of the cement will decreases. If the particle size of the cement is decreasing, then surface area will go on increasing. So similar concept is there here also. um, Normally of course the shape of the particle also, that's very important. In case of cement, if the shape of the particle, um, if it is like what triangular shape, normally the surface area it will be very less. If the particle size of the cement particle is circular in nature, or it is rounded, then normally um, the surface area will be more, because less voids in a circular shape of the particles. Sieve analysis is very important. With help of that, we are determining the particle size. There also in cement we are not doing any sieve analysis to find out the particle size. Sieve analysis is also called as a particle size value in determination of proportions of the particles with in a certain range of an aggregates by separation on various sieves of different size openings may be defined as a sieve analysis. Normally in the sieve analysis you all did in a GT lab, we will arrange it in different sieves. Then at the top we will weigh it initially. For example, 1 kg of aggregates will take it of different sieves, and we'll arrange it either manually or mechanically. We will start saving it. Then some of the aggregates will pass through some of the sieves, and some of the particles size of the aggregates will retain on the sieves. Then percentage gradations also we will calculate it, and we will draw the curve normally in log sheet based on the percentage finer percentage gradations, and based on that we will calculate or we will design it for the strength of the concrete. Of course, with this sieve analysis, we will do the gradations also. So 20 mm grade 20 30 percentage gradation, uh, um, that is 20 mm 40 mm aggregate, 40 mm aggregate, how much percentage it is there, 20 to 30 how much aggregates is there. Based on that, we will use it when we are calculating the strength of the concrete. Normally I already said that when you are calculating the particle size, fineness modulus is very important. So then fineness modulus can be calculated by cumulative percentage of aggregate that are retained in each sieve. I already said that way, um, um, 1 or 2 kg or 10 kg of the aggregates, then go on sieving it. Then finally uh, take how much retained on each, take it separate it. And when you are sieving also, you have mechanical sieving is there and manual sieving is there. When you are doing it mechanical sieving, minimum 10 minutes you have to run it. When you are manually, if you are doing it, minimum 15 minutes you have to run it. So then after that, each sieve take it out and weigh it, and um, take the weight of that. So find out how much percentage of aggregates are there in each sieve. For example, if you have taken 10 kg, if you got 20 mm as 1 kg, then it is 10%. Means in 100 kg, if you taken, if you are saving it, suppose if you got a 10 kg of 20 mm aggregates, it is 10% of um, aggregates retained on um, 20 mm sieve. That is how you have to calculate it. So normally if you see these diagrams, um, here you can see uh, the um, a mechanical type of sieving machines are there, and that is two different, one is a round shape and one more is a rectangular type of sieve. Left hand side you can see that that is a rectangular type of sieve, and on the right hand side you can see that that is a circular type of sieve. So then that is the diameter, normally diameter of the sieve, and that is the depth of the sieve. Then flakiness and elongation index. So flakiness is always will tells about the shape, what kind of shape it is there, and elongation is always tells about the length, how much length it is there. So then normally we will use it the different types of gauges here. So then with that gauges we are going to determine the how much elongation is there and how much flakiness is there. So normally number of flaky particles, if you take it, so normally it will creates lot of voids, and if lot of voids are there, then it requires more mortar or more cement concrete mix to fill it, because more voids will be there. If more voids it will be there, then means more concrete is required, more cement is required, um, more mortar is required, or and it is not economical also, then it affects the durability aspects of the concrete. So therefore it is better to find out what will be the flakiness and elongation index of the aggregate. It play a major role even when the mixing of the concrete also. I already said that if more flakiness and more elongation index it will be there, then the strength is going to reduce, the gradation will not come. Once the gradation is not coming, then you have to use more aggregates. When you are using the more aggregate, then of course the quantity, of course you are reducing the quantity of cement and the quantity of sand, but it is going to reduce the strength and it is going to reduce the overall mix of the concrete. For example, if you are doing it for a high strength concrete like M60, M80, M120, M150, normally the flakiness and elongation type of particles will not use it, and it is avoided, it should be less than 1%. So aggregates normally, if you have a flakiness and elongation index is more, this kind of aggregates may, and of course it is going to break down easily under heavy loads. If it is a flat type of aggregate is there, and if you put a load on that aggregates, then normally it is going to break. Of course if you apply point load, definitely it is going to break. If it is like what a flat load, if you are applying it, of course it is not going to break. Means a flat load means in all that surface you have to apply constant pressure. Of course if you apply point load on this kind of flakiness aggregates, then normally it is going to break. It is also called as a shape test. I already said that it is tells about the different types of shapes. If you want to find out this flakiness and elongation index, you have to use IS code of 2836 part 1 to find out the flakiness and elongation index. So then how we are going to find out this test? So to find out this test, apparatus are required are aggregate sample. What you have to do is that whenever you are taking it, you take some weight and take it. So the aggregate sample it is required, then a digital balance to weigh the uh, aggregate. Then you require two gauges here, very important, two gauges. One is elongation gauge and one more is thickness gauge. Elongation is gauge is to measure the length of the each aggregate. Then thickness of the gauge is to find out the thickness of the each aggregate. So then normally in one IS code, what we'll do is that we will weigh the aggregate and we'll take it. Then in that we'll find out it how much percentage of aggregates are of this size and how much percentage of are of this stage. Or in one more IS code, in the same code, or we can do it in one way, other way, that is we will count the number of aggregates. For example, we'll count the 100 aggregates. In that 100 aggregates, how much percentage are of this is shape and how much percentage are of this shape, how much percentage are of this much length, how much percentage are of this length, and we'll broadly will categorize it. Okay, uh, uh, length of 10 mm to 20 mm, how many are there? 20 mm to 30 mm, how many are there? 30 mm to 40 mm, how many are there? Then we'll categorize it. Then we will see what will be the variation of this elongation and the um, mm, thickness of the gauges. Then different sieves of size like 63 mm, 50 mm, 40 mm, 30.5 mm, 25 mm, 20 mm, 16 mm, 12.5 mm, and 10 mm, and the least is 6.3 mm sieve. Normally we will use it for um, sieve analysis and to find out the elongation as well as the thickness of the gauges, and that also will take the um, one graded size like 20 mm retained, 25 mm retained, and that we will take it. Of course, this is elongation gauge. We can see that different graduations are there. uh, in that elongation gauge, you can if you go from left to the right, the slot in between, if you see the different slots, the slot size is increasing as it move towards the means, mm, where your um, aggregate is fixing, that you have to determine. If you are taking 100 aggregates, all that 100 aggregates, what you have to, each aggregate what you have to do is that take it where it is fixing, and finally, for example, first slot in that aggregate, if you have 10 aggregates are fixing, then find out it. In the second, assume it as 20 aggregates. That means 10 percentage or of the first length, that from the left to right. Then the 20% means 20 aggregates are coming in between the second slot. It is in that range it is coming. So in that way, finally calculate what will be the percentage of elongation index. And this is thickness gauge. You can see that in each gauge they are fixing it and they are determining the thickness. Procedure: take the aggregate sample which contains minimum 2 faces of any fraction. So means minimum it is 200 pieces they are telling. You can take 100 pieces also, not a problem. You can reduce it to, and you what you can do is that for 100 pieces you are getting, for 200 pieces how much you will get it. But normally take it 200 pieces, any fraction randomly you can take it. It is not like a graded. In a bulk of sample, in bulk of aggregates, take 200 pieces of sample. Don't grade it by when you are taking it randomly, you can take it and do it. Sieve the sample through mentioned sieves, that is whatever the sieve I already told, that you take it, sieve it from 63 mm to 6.3 mm sieves. From highest is 63 mm and the least is 6.3 mm sieve. The aggregate retained on 63 mm and passed through 63 mm should not be considered. This is very important. Normally, aggregates above 63 mm and the passing 63 mm, that should not be considered, because the above 63 mm it has less applicability, and less 63 mm it has also less applicability. Normally less than 6.3 mm, it is normally considered as a fine aggregate. It cannot be considered as a coarse aggregate. And if we are saying the coarse aggregate, and should not exceed greater than 63 mm size. So if it is normally 63 mm, greater than 63 mm size of the aggregates will be used for the sub base in designing the roads. Normally this 63 mm, greater than 63 mm of aggregates are used uh, wherever uh, the strengthening of the subbase layers in um, the roads. When they are designing the roads, it is required. Of course wherever the subbase layer is weak or subgrade layer is weak, in that cases you have to um, add greater size of the aggregates, so that that has to be strengthened, and the CBR value should be increased for about 20. Then above that you can use different gradations of the size and compact it. So normally um, to strengthen the subbase layer of the roads, 80 to 100 of aggregates will be used, and it is compacted with the uh, roller. Normally 100 tons of roller will be preferred in case of strengthening the 80 to 100 of aggregates. On that you can use the different gradations of the aggregates along with the um, different types of cement to aggregate ratio, or cement mixed with um, wet based macadam. Normally we can call it as WBM, wet based macadam. We will use it and we will compact it. Of course it has a lesser applicability, so that is why it is neglected. And when it comes to the lesser size, that is the less than 6.3 size, um, that will be used for asphalting works. Normally asphalting works it will be used, and sometimes nowadays this lesser than 6.3 size they are using for the preparation of sand. So they are using this size for the preparation of sand and for using some of the crusher powder. Of course this crusher powder has its use in mm, after asphalting. Normally this crusher powder will be sprayed so that um, whatever the tar is there or the bitumen is there, it should not come in contact with the mm, tire or the vehicle which are moving on the roads. Or immediate if you want immediate road has to be uh, opened for many reasons. In that cases the crusher powder will be used. Of course the crusher powder is very dangerous, and it will create the respiratory problems when it go into the human body. So based on the applicability, this crusher powder will be used, and less than 6.3 aggregates can be used for preparing the crusher powders. So now weigh the aggregate retained on different sieve and note down the total weight as W1. Now weigh the each you will get it different sieves and weight, that is W1. For determining F5, aggregate retained those sieve are to be separated. Now each aggregate is passed through corresponding slot in the thickness gauge. Already said that if you are taking 200, then um, pass each of those aggregate and pass it through that gauges. See that all those uh, particles are passing through which gauge, and finally determine it in which gauge more or or is there any variation in between this flakiness, or is there any variation in the elongation of each of those particles, and find out it how much percentage of uh, um, elongation is there of each of the aggregates. So then flakiness index, that is W1 by W2 multiply 100, where W1 is the weight of the aggregate passing through the slot of thickness gauge, and W2 is the total weight of the sample. Then moisture content, a sample of 2 kg, of course it is a similar concept of determining the moisture content of the soil. The similar concept or similar thing we will do it there. We are weighing the soil, and here we are using the aggregate. So a sample of 2 kg of aggregate is used for conducting the test. Here minimum we have to use it 2 kg, but when you are doing it for the soil, normally we will not use it that much. Of course we have a small cup of we'll take it. Normally it is made up of the copper. Then we'll it's a small type of copper box it will be there, or that one we will take it, and we will initially we will weigh it. Then we will keep it in oven for about 105 degrees centigrade or 104 degrees centigrade, then for 24 hours. Then after 24 hours we will take it out and we will cool it. Then we will take the final weight, and the difference in the soil uh, is the moisture content. Similar concept and similar method we will use it in this uh, uh, determination of moisture content of the aggregate. So then first 2 kg of aggregate is used. The sample should be thoroughly washed to remove finer particles. Normally our aggregates, sometimes it consists of um, the mud particles that has to be removed first. So then the dust, sometimes it will be there, that has to be removed with the water. Then place in a wire basket and immerse in a distilled water at room temperature for about period of 24 hours. Why you are using the distilled water here? Normally we can use it in normal water also, but we have to use a distilled water only. In the distilled water no ions it will be there, or no such kind of dissolved solids will be there. Normally we have different kinds of solids are there. One is suspended solids, second one is dissolved solids, the third one is colloidal solids. The suspended solids, these solids are visible through our open eyes. Mud water, normally it consists of suspended solids. Then colloidal solids, they are all charged particles. And best example for colloidal solids is when you add 1 or 2 drops of milk particle into the water, it will disperse into the water. You can see the it will convert it into slowly uh, that that is milk color only. That color of water is due to, that is due to colloidal particles. And one more best example, you take a small amount of lime powder, or you can take the chalk powder, which is always fine, and try to add it into the water, mix well. Even you can see the whichever the particles are there, they are all nothing but they are all colloidal particles. Of course the size is very less, size is very less compared to the suspended solids. Then when it comes to the dissolved solids, these are all dissolved in nature, means you cannot see it but colloidal and suspended solids you can see at least through your open eyes, but dissolved solids you cannot see it through your open eyes. Only you can determine by using the conductivity meter or by using the conductivity. If you use the conductivity of the sample, maybe you'll come to know how many total dissolved solids will be there. Or you have to do it by one method. What you can do is that take the water sample which consists of total dissolved solids, then try to pass the that sample into uh, that filter paper. Neglect the whichever the particles are retained on the filter paper, and some particles will filter through that filter paper. Then what kind of filter paper we have to use it here? Then normally we will use it Wattman 42 filter paper to filter this sample. So once this sample is filtered, you can see that some of the solids will pass through that filter paper. Once this solids are filtered through this filter paper, then take it out whichever the particles are there, then uh, keep it in oven for about 24 hours. Then whatever the water it will be evaporates. Then at the bottom of that beaker you can find that small size particles or white type of precipitate type of particles we can find, which are very fine in nature. If you weigh that, or if you take the weight of that particles, then how you have to take the weight of that particles? Initially you take the empty weight of that beaker before transferring or before filtering it. Then after filtration and oven drying, take the final weight of that beaker. Then you will come to know that how much will be the total dissolved solids. One method of determining the total dissolved solids is um, using conductivity technique, and one more is with the oven drying method. Of course, oven drying method is more accurate than the conductivity. Then I already said that distilled water does not contain any dissolved solids, means the conductivity is very less. Normally if you use a normal water, it consists of many dissolved solids and it is going to absorb by your aggregates. Once it is going to absorb, you want to get correct moisture content of the aggregate, and these dissolved solids will not allow this will not allow uh, this aggregate to won't dry it completely. Even if more dissolved solids are there in water, if you immerse it in aggregate, normally the aggregate reaction is going to happen. The aggregate, for example, alkali aggregate reaction, that is one best example of um, uh, this method. Normally when it is going to happen alkali aggregate reaction, water is required. I already said that water is most important. Like that, if water consists of more alkali is nothing but dissolved solids. These dissolved solids are going to react with the alkali and it will disintegrate and it will change the property of the aggregate. Once it is going to change the property of the aggregate, most of the time you won't get the correct value of the aggregate, and you won't get the, even if you keep it for 2 days, you won't get the moisture content, and you are not going to lose the moisture content. And this is not the standard method of determination of the moisture content. Then aggregates are removed and gently surface dried with a dry cloth and weighed. The aggregate then placed in an oven at the temperature of 100 to 110 degrees centigrade for 24 hours. After 24 hours, aggregates are removed and cooled in airtight container and weighed. Of course, you have to take it out and you have to weigh it. Then water absorption ratio, that can be calculated by W1 divided by W2 multiplied by 100, where W1 is the weight in grams of the surface of the dry aggregates. Very important, it is the dry aggregate. So W8 is the gram in O1 dry aggregate, surface dry aggregate. It is O1 dry aggregates, very important. And water absorption shall not exceed 2%. And normally, if so when normally it is going to exceed, your water absorption ratio is going to increase. Normally, if more elongation index or the more flakiness index is there, or if you are exposing more surface area to absorb the water, in that case it is going to more moisture content is going to increase, or absorption is going to increase, because more surface area is exposing to the water. Or if we have more cracks inside the aggregates, then of course in the cracks also the surface is going to expose to the water. There also the water is entering, there it is retaining, and the temperature will not go inside the aggregate. Maybe 1 or 2 depth your temperature is going to uh, uh, enter, and above that it is not going to enter. So if more cracks it will be there in the minor cracks, even sometimes minor cracks you cannot find it through your open eyes. If more cracks are there, in the cracks the water is going to enter. When the water is going to enter, normally you are going to lose the uh, more water, and the more absorption water is going to absorb. Then when more water is going to absorb, normally your water to binder ratio, that is 0.45, it is going to affect. And as for the IS code, water to binder ratio, that is 0.45, when it is going to obstruct or when it is going to disturb, then the normally it is the strength of the concrete is going to reduce. So care should be taken when you are using the aggregates. Moisture content has to be determined first, or what's the absorption ratio can be calculated first before determining any of the uh, uh, any of the test. Maybe uh, uh, this property we will discuss in the next class. Thank you. Of course, the specific gravity also is a very important characteristics. That also it is similar to the specific gravity of the water. How we are going to find out the specific gravity of the water? That is the um, density of any liquid to the density of water here. Same concept we will apply here, find out in the specific gravity of the water. Of course, when you are discussing about the density, you have two types of densities are there. The one is mass density, and one more is the weight density. The mass density, normally mass density unit is kg per meter cube, and weight density unit is Newton per meter cube. Means in weight density we are considering the acceleration due to gravity, but in mass density we are not considering any acceleration due to gravity. Means there we are considering mass, here we are considering the weight. Of course, specific gravity can be determined with the help of the mass density as well as with the help of the weight density also. Similar concept, we will find out the specific gravity aggregates. Maybe here when you are calculating the specific gravity of the cement, normally we will use the kerosene. When you are calculating the specific gravity of the petrol, we will use the water as the standard. When you are using specific gravity of the diesel, will use the water as the standard. But even when you are considering for the sand as well as the aggregate, we will use the water, except the cement. We will not use it. In the cement only we'll use the kerosene, but for another type of materials we'll use water as the standard to calculate the specific gravity of the aggregate. Of course, um, the density concept, I'll explain it one more time in the next class. Of course, uh, uh, when you are calculating it for sand, um, we will weigh it, and um, for example, 1 kg of sand we will weigh it, and we will transport it to one vessel, then we'll add it, then we will take the weight along with that um, vessel, then we will take the um, uh, initial weight and final before initial weight before adding it, final weight it, when you are calculating the specific gravity of the sand. Similar concept we will add it here when you are calculating the specific gravity of the aggregate also. This we will discuss in detail in the next class. Thank you.